Well, good morning, everyone. I'm excited to be here today to talk to you about a new innovation in IT infrastructure. My name's Jay Menon, and I've been in the IT infrastructure business for close to 30 years, having had roles as CTO for IBM and then later CTO for the systems business at Dell. And as I've watched infrastructure over all these years, every 6 or 7 years or so, a new kind of innovation happens that makes it so much easier to consume that infrastructure. And I think that what I want to talk to you about today is that next generation of IT infrastructure. And um, the uh, the product is called Ignite, and the company is Cloudistics. And we're going to talk to you about what we're calling this fourth generation platform. And it's all focused on the idea that we're going to make it as easy to consume as it is to consume the public cloud. So it's going to be just as easy to use. The only difference is that the infrastructure is going to be on your premises. You have control over it. You have governance over it. You don't have to worry about your data being in the cloud. And it's a very exciting development that I'm going to talk to you about. So here's the outline of my talk. As I mentioned to you, I've talked to a lot of CIOs over the years, over my career in IT infrastructure. And I'm going to summarize what I think is most important to the CIOs and to the folks running the infrastructure. And I'm going to compare those business needs against current architectures, because it's my point of view that current architectures and current infrastructures don't really satisfy all of the needs that I have heard over the years. Then I will introduce a new kind of infrastructure, one we're calling Superconverged, and I'll tell you why it's called the fourth generation in a minute. But just to put it into context, the third generation of infrastructure is hyperconverged infrastructure, which is getting a lot of play today, and it is at the top of the hype cycle. Somewhere around 40% of the enterprises today have hyperconverged infrastructure for at least one of their applications. So we think of that as the third generation, and I'm going to talk to you about the fourth generation, what comes after hyperconverged. Following that definition of what is superconverged, I'm going to talk to you very specifically about the Ignite product, Cloudistics Ignite, what makes it different from all of the other kinds of infrastructures you're likely to see or buy from vendors. And then I'm going to circle back and tell you exactly how it supports all of the business needs that we have seen and we have heard from CIOs. And then I'm going to summarize. So that's what you're going to hear from me today. So here is a very simple point, a simple way to summarize all of the business needs on infrastructure that we have heard about from CIOs. And it's not in any particular order, but there are 6 of them. Number 1 is workload diversity. CIOs run lots of different kinds of workloads. Customers run lots of different kinds of workloads. There's legacy workloads. There's new workloads that are coming like Splunk and Hadoop and Docker. And really, IT infrastructure people don't want to have to buy different infrastructure for each one of their different applications. You really want to build upon and run on top of an infrastructure that accommodates all kinds of applications. The second and third bullets are really around cost. So one is what I would call CapEx, that's bullet 2, and the bullet 3 is really around OpEx or operational expenses. So you clearly want something that is low in cost, but that alone is not enough. You can buy something low in cost and give it away through poor efficiency of how you use the infrastructure. If you have something that has cheap storage, but then you require the customer to buy twice as much storage as he really needs for availability, then you've sort of given away the low cost. So you really have to think about cost and efficiency together. And it's not just about the hardware, it's about what other software from other third parties do you need to buy to make your infrastructure usable, efficient, and operational. So all of that goes into that second bullet. The third bullet is hugely important, and it's a lot of the reason why customers might think about going to new kinds of infrastructure or going to the public cloud. It has to be very, very easy to deploy. You have to be able to plug it in and have it running in minutes. You have to make it very, very easy to manage and very, very easy to use. So that's a very important criteria that we have heard in my discussions with CIOs. The fourth one is consistent high performance. High performance is, of course, obvious, but on top of that, it needs to be consistent. You can't have high performance sometimes, but then if you're running other applications at the same time, that you lose your high performance. It can't be that high performance depends upon good caching, and if your data doesn't sit in the cache properly, and it's off the cache, then you lose performance. So you got to have it be consistent, and that's important. Obviously, it has to be business resilient. You can't have your compute go down and have your app stop running, or you can't have your storage go down and have you lose data. So that's a very important thing. And finally, you really want to have the infrastructure be open. It must meet and adopt open standards. You can't have closed standards. You can't have it such that the hardware is only available from one place. It has to be future ready. There's new kinds of application development techniques coming along, like microservices. You need to be ready for that. There's new kinds of hardware becoming available, faster forms of flash, newer forms of buses. You can't have your infrastructure be a few years behind and not be able to use the latest advances in technology. And so that's an important thing, to be open and future ready. So those are the 6 things. You'll see as I walk through these, the rest of these charts, that we will come back at the end and talk about the infrastructures and how they satisfy these 6 goals, because those are indeed what IT infrastructure needs to be able to satisfy. So let's talk a little bit about the current state of the world. What are the kinds of infrastructure that you can go out and buy today? What's good about them? What's bad about them? And why did we decide that these are not good enough, that we really needed to innovate and create a new kind of infrastructure? So let's start with around the year 2000, when infrastructure was bought in a very siloed way. So customers went out and bought the best servers they could from, let's say, an HP or a Dell. They bought the best storage they could from companies like EMC and NetApp. And then they went out and bought the best networking equipment they could from companies like Cisco. And then the customer took the effort to put all of these different parts together, and it often took many months to make sure that these different parts worked together, worked with each other, and that the application that they were interested in running, or the many applications that they were interested in running, all worked properly on this. And so the time to value to the customer was several months. They really had to be prepared and spending several months of effort before they could actually run the first bit of code, the first application, to provide real value to their business. So starting from around 2007, a second generation of infrastructure started to be available. And this is called the converged infrastructure. I was at IBM at the time. We actually had a converged offering called Pure Systems, IBM Pure Systems. Probably the one that a lot of people are familiar with is VCE, and they have an offering called vBlock, fairly well known. And the idea is to try and reduce that upfront multiple months of effort to time to value. And so the vendor takes the effort to pre-test and integrate server, storage, and networking. It's still really 3 different products that you are putting together, but the vendor takes the effort to put all those 3 products together so that the customer's time is saved, and they can more quickly be running their first application. Perhaps it takes a month instead of 3 months, perhaps it takes 3 weeks. And so there's a significant reduction in the time to run your first application. But remember, at the end of the day, you really still have 3 products. It's a little bit like putting lipstick on a pig and trying to pretend it's one product. Really, under the covers, it's really still 3 products. But you've done some effort to make it easier for the customer. There are other advantages shown in black in the middle rectangle there. You are able to scale the server component, the storage component, or the network component independently. This is good because some workloads need more storage, some workloads need more compute, and converged infrastructures can satisfy a diversity of workloads. Furthermore, they use storage area networks, which use techniques like RAID to very efficiently provide redundancy. You don't have to have an extra petabyte of disk to support 1 petabyte of customer data. You might need another 10% or so with techniques like RAID, and that is very good. The main problem with converged infrastructure is, at the end of the day, it's really 3 products. You know, it's pretending to be 1 product, but it's really 3 products. And furthermore, in particular, the storage is proprietary and expensive because SAN storage is proprietary and expensive. And even the disks or the flash devices that go into the storage, actually, you would have to pay typically anywhere from 50 to 100% more for the same device versus putting that same storage device in a server. So putting it in a SAN device just jumps the cost of the storage component. And fairly complex to manage. It's fairly complex to manage the whole box because you really have 3 different boxes that you're trying to make look like 1. And the storage piece in particular is quite difficult because SAN management is complicated. You have to worry about things like LUN masking and multipathing and all kinds of complications that arise with SANs. And this is exactly what the 3rd generation of infrastructures attacked. The problem of really, you really have 3 products, the storage is expensive, the SAN is complicated to manage. And so Hyperconverged came along and said, look, I'm really going to give you 1 product, not 3. It's a hyperconverged product, and it's going to be simple to manage. The storage is going to be low cost. I'm going to get rid of the SAN and use directly attached storage on each of the server nodes of the hyperconverged offering. And so they really solved some important problems with the 2nd generation. The problem is that they still left open several issues, and in some ways they went backwards. You know, in some ways they took some things that Converged had done right and kind of undid them. So let's talk about those for a minute. So they made storage simple, but they didn't do anything about the network. And as many of you know, networking is actually the thing that is hardest to make agile. If you go to your IT shop and ask for a bunch of resources to run your application, it's actually fairly easy to create a virtual machine and have some storage with it. The part that takes 3 weeks to do is all of the networking and the security around those resources. Who can talk to it, who can't talk to it, what's the networking, and that's what takes 3 weeks to do. So by solving just the storage piece but leaving the network piece out, we feel that a big component of what is needed to make the data center agile is missing. Secondly, they went backwards with respect to the ability to scale the 3 different components in an independent way. With Hyperconverged, you really get coupled scaling as opposed to independent scaling. So you really when you buy a hyperconverged node, it comes with storage and it comes with compute. And so it can be in different ratios, but nonetheless, you are actually scaling both compute and storage. That's a good thing for certain kinds of workloads. VDI is a good example, and in fact, lots of hyperconverged offerings initially and to this day are very focused on the VDI workload, because for that workload, coupled scaling makes sense when you need more compute and you need more users for your VDI solution. They also need more storage at the same time. But that is not true for a large set of workloads. And so that, in that sense, they took a step backwards from what Converged was able to offer. And then the last problem that we see with hyperconverged is that they do storage redundancy in an inefficient way. And in particular, they do mirroring or replication as a way to ensure that the storage is redundant. So they make 2 copies of all of the data. If you have a petabyte of data, then it needs another petabyte of redundant copies that you have to keep around. And the reason for that is that RAID is very hard to do when the compute and the storage are integrated together in one node, because you have to do a lot of network operations to do RAID to connect with other compute and storage nodes. And so the typical way that most hyperconverged systems operate is to use replication. So in that sense, also, they took a step backwards from what Converged was offering. So that's kind of the state of the world as we know it today. I would also point out that if you go out to current data centers, about 80 to 85% of those data centers were populated using the siloed first generation of infrastructure. About 15% uses the converged type of offerings, and about 5% use hyperconverged. On the other hand, the hyperconverged is the fastest growing of the 3. As you can see, it's growing at a 36% compound growth rate. The siloed offerings are growing at 0%. So over time, we're going to see more and more of hyperconverged. And that does make sense because, as we have pointed out, it solves some problems with siloed and converged. But it's not perfect. As the red on this third rectangle shows, there is still room for improvement. And this is why we decided at Cloudistics that we really needed to do something better and beyond what hyperconverged has to offer. So let's talk about superconverged. And superconverged is really, in our point of view, it's the 4th generation. It's after hyperconverged. And what is superconverged? Well, the simple way to think about superconverged is, first of all, we want to keep the best of hyperconverged. You know, it's a single product. It's not 3 products under the covers, 1 product. We want to do the same thing. It's 1 product. We want to keep it very simple to manage, same thing. We like the use of low-cost storage. That's a good thing. So we start with all of the things that are good about superconverged. But we also want to keep some of the advantages of hyperconverged that was lost when we went to hyperconverged. So we want to keep things like efficient storage redundancy using RAID instead of replication. We want to be sure that all of the components, storage, server, networking, can scale independently. We don't like the idea of coupled scaling. It just makes it harder to run certain kinds of workloads. This is not what CIOs want. And so it's really important to ensure that independent scaling is possible. So superconverged is really keeps the best of hyperconverged, and as we just talked about it, it also keeps the best of converged. And then we asked ourselves, is that good enough, or do we need to add some more capabilities? And we went back to, what is it we're trying to do? Well, as we said at the very beginning, we're trying to be the ideal on-premise cloud infrastructure. We want to be as simple to use, to consume, to deploy as the public cloud. And so we've got to bring some things in that are similar to what an Amazon or an Azure, etc. might be doing. And so the first thing we said was, you can't really be simple, and you can't really be competitive, and you can't really be agile as a data center unless you really simplify network management. So we are absolutely simplifying network management, and we'll talk about that. But without that, we don't feel that you have a real offering. Secondly, everything is going to be managed from a single pane of glass. With Converged, there are often 5 or 6 different pieces of, consoles that you have to manage things from. If you take a product like VCE, you need VMware vCenter Manager. You need from Cisco, you need the UCS Manager. And then from EMC, you need things like PowerPath and Ionix and a couple of other products. So there's like 5 or 6 different products that all come together under the covers, and 5 or 6 different consoles to manage something like a VCE. And even if you look at Hyperconverged, since Hyperconverged never integrated networking, all of the management of the networking is through a different console. And depending upon whether you're using VMware or something else, often you'll still need a vCenter console in addition to the Hyperconverged console. So there's maybe 2, maybe 3 types of consoles. And we just took that final step and said, look, we've got to make it all one single console. It's got to be everything managed from one place: server, storage, networking, the virtualization, and the applications. All of that has got to be managed from one place. It's got to be a transformational user experience. And then the last thing we told ourselves was, look, what are we trying to do with infrastructure? At the end of the day, you're trying to run applications. In some ways, you really want the infrastructure to be invisible. And if you can make it as easy as possible to run applications, and all of the management is done in an application-centric way, not just storage management, but network management, security management, all of that needs to be done in an application-centric way. If you can make it really easy to say, I want to run Splunk, click here, that is so much better than being able to say, oh, somebody needs to know that Splunk needs 32 cores, and it needs 4 terabytes of memory, and it needs X petabytes of storage, and so let me go and ask to create 32 cores, and et cetera, et cetera. That is just so much more complicated than being able to go to an app store or an app marketplace and click on Splunk and have the system know that, that means I need to go carve out 32 cores and 4 terabytes of memory and so on. And so we took the next step to say, look, at the end of the day, this is about running applications, and we've got to make it as easy as possible on the people running the applications to hide the infrastructure and to hide all of the details of what it takes to run those applications. So this is an important chart, so I'm going to repeat what I just said. What is Superconverged? Well, it's got all of the benefits of Hyperconverged: low-cost storage, simple management. It's got all of the benefits of Converged: efficient redundancy of storage, independent scaling, and it's got 3 new capabilities: simple network, transformational user experience through a single pane of glass, and everything is application-centric through things like an application marketplace. So hopefully that is a good introduction to Superconverged and how it's different, why it's important, and we'll come back and circle to the original 6 requirements and show you how we are now able to satisfy those 6 in a much better way than Hyperconverged or Converged or all of the earlier forms of infrastructure. So we really do believe this is an innovative and important next step in infrastructure. So let's talk a little bit about specifically Cloudistics Ignite, the product. You'll see 2 charts that I'm going to talk about. This chart is a little bit more hardware focused. The next chart is going to be a little bit focused on all of the software, which is really the smarts that makes up what Superconverged is all about. So as you'll see in this chart, you'll see 3 blocks. You'll see a compute block, you'll see a storage block, you'll see a network block. The compute block is a 2U, storage block is a 2U, the network block is a 1U, so there's 5U here in kind of the basic entry Superconverged Cloudistics Ignite offering.
It's very different from the 3 blocks in a converged offering, because the 3 blocks in a converged offering are really 3 different products that were not intended originally to work together, and then you're putting some sort of lipstick on top of all of those 3 products to try and make it look like one. This was designed from day one to all work together, so it is very different from seeing these blocks in a converged offering. So let's start with the compute block, which is at the bottom. You can see that you can have anywhere from 2 to 8 nodes. They use the very latest and greatest Broadwell Intel Core chips. You have anywhere from 10 to 14 cores a socket. And if you look at that 2U, you can have up to 448 cores in that 2U. There's a lot of compute capacity. And you can have anywhere up to 4 terabytes of RAM in that same 2U, which is, again, a lot of memory. Now, here's the interesting thing. You can scale this compute block independent of the storage or network block. So you can add more compute blocks, and you can keep adding. Unlike some of our competitive solutions, for example, with VMware, you're limited to 32 nodes in a cluster, and you can't go beyond that because of limitations of software. We have no such limit. So you've got 8 nodes here. You can keep adding more compute blocks, and you can keep adding more compute blocks, and there's no limit of 32 nodes in a cluster. It is very, very scalable in a hyperscale sense. Let's look at the storage block. Within that storage block, we have 112 terabytes of raw storage, approximately 100 terabytes of usable storage in a 2U. That is very dense. I mean, you can go and look at a lot of other offerings and see how much storage you can get in a 2U. That's a lot of storage, as I'm sure you'll all recognize. And in our case, we use all flash storage. There are 32 flash modules in that 2U, we don't really have the complexity of there's some spinning disks, there's some flash. Somebody has to tier data between those. Customers have to decide where they want their data. This is all very simple. There's no choices. It's very simple. We know that flash prices have come down tremendously, and so we think that it just makes perfect sense to make it an all-flash array. And the performance is outstanding. You can get anywhere up to 200,000 ops per second in that 2U with 150 microseconds of latency. And you can keep adding storage blocks for scalability, just like you can add compute blocks for scalability. So if you want to add more storage blocks, you can. If you add a second storage block, now you've got 400,000 ops per second. If you add a third storage block, now you've got 600,000 ops per second. So you get linear scaling of performance. We'll talk a little bit more about some of the other advantages, but great density, great performance, and linear scaling. Hard to beat. And finally, let's talk a little bit about the network block. This is a 1U, and you can see that you've got a lot of ports, 48 ports at 10 gig, and then 6 ports at 40 gig to connect up to higher levels of a leaf spine type of architecture. We use the same leaf spine architecture that Amazon and other cloud vendors use, so that, as you know, we're trying to be the best on-prem cloud, and we want to do things in a very similar way. We build our network to be very scalable, just like we built our storage and compute to be scalable. It is all auto-configuring, auto-discovering, auto-deploying. As you add more switches, the system automatically knows which things are leaves, which things are spines, what needs to be connected to what. And so it's just very, very simple to grow, to deploy the whole thing. And then on the left, we have in the cloud a controller to manage all of these components. It manages all the low-level hardware, it manages the hypervisor, it manages the network, the storage, the compute, the security, and the applications all in one place. One console. As we've talked before, our competition typically has 3, 4, 5, 6 consoles. So this is absolutely transformational.
in how we manage all of this stuff. We have an application marketplace, and you can see some of the kinds of apps that you can find in our application marketplace. Not all of these apps are there today. Some are coming, but you get the idea. The idea is that it's a lot like an iPhone with an app store, same kind of concept, make it really simple to run the applications. So when you put it all together, you get the benefits that we show on the rectangle in the blue on the top left. This is really simple to deploy and provision. You get very high performance, and oh, by the way, it's very consistent because of use of all flash and no spinning disk. It's all managed from a single pane of glass. You can actually, from a single pane of glass, manage infrastructure that might be located in multiple data centers in multiple geographies around the world. And all of this scales on demand. Any piece of it that you want to scale scales. And we've done the TCO work. It's very easy to compare costs against something like the Amazon public cloud, because the prices are all there for you to go look at and compare. We're easily a factor of 2 at entry, and the difference between us and Amazon can only grows as you add more nodes to the system. We've also done comparisons against competitive hyperconverged offerings, and we see the same factors of 2 compared to those other offerings. So we believe we are the lowest TCO in the market as far as infrastructure goes. Now let's talk a little bit about the software. And this is, of course, where a lot of the key differentiation comes in for our Ignite Superconverged product. And there are 4 key pieces of software. And before I get into the details, I'm going to read you the highlights, or the highlights or the headlines on each of these 4 components. So the first component on the top left is the thing that gives us true network agility. It's the thing that we think is the thing that no one else has really addressed, and the thing that is really important to address to get true data center agility. Not enough to have compute agility and storage agility, you need network agility. That's what that component, which we call AON, gives us. Then you go down to the bottom, and essentially this component gives us world-class resource management, except you don't have to pay the VMware tax, because you get all of that functionality. Everything VMware's got, we've got, even better in some cases, through things like hot add support for CPU and memory, through scaling, etc. But the price, it's all built in to the product, so you don't have to pay separately for VMware. So we give you everything VMware Hypervisor and vCenter does, but we don't charge you for it. You go to the bottom right, and all of that stuff in green essentially says you have an enterprise storage product here. You have an enterprise storage functionality, enterprise storage performance, but you don't have to pay the cost that you do today for enterprise storage. And then finally on the top right, we've got the transformational user experience, everything from one console, a built-in application marketplace. Just a little bit of detail now. I wanted to share the headlines, but let's go back and talk a little bit about each of these components. The way we do network agility is by doing built-in network virtualization. So those of you that are familiar with VMware's NSX product, essentially that does network virtualization. You have to pay thousands of dollars per node for NSX. We've got that capability built right into the product. But not only that, the NSX product and other products that do network virtualization all work at layer 2. They all do encapsulation, which is a very CPU-hungry operation. We figured out a way to do all of this at layer 3, which means that it's at a much higher level. Layer 2, you have to deal with low-level things like ports and stuff like that. We don't have to worry about any of that stuff when we work at layer 3. And we figured out a way to do it without encapsulation, which is a CPU-hungry operation, as we talked about.
And so we can now give you virtual networks that operate at line speed. So if you have a 100 gig physical network, we can give you a 100 gig virtual network, which is really not possible to do with the other network virtualization products. You might often take a 100 gig network and get a 10 gig virtual network because of all of the overheads of doing things like encapsulation. Furthermore, you have to do routing in a virtual network if you're moving, if you're sending a message from one virtual machine on virtual network A and you're sending it to another virtual machine that's sitting on virtual network B, some routing has to happen. And that routing typically in physical networks happens with a hardware router, your switch or your router, which you've already paid and bought for. But in a virtual network with encapsulation, that hardware is not useful to you to do virtual routing between VNet A and VNet B. So you have to have some software sitting on some node somewhere in order to do software routing, and that is also very expensive in CPU. So often when you're running network virtualization, there's often another bank of servers that are doing nothing but software routing. In our case, we figured out in a patent-protected way how to do virtual routing, but using the existing switch/router that you already have. So you don't need software routers, which means you don't need extra CPUs and servers and nodes to do software routing. So it's a very powerful approach. But at the end of the day, what does all that give you? Well, it gives you network agility, and that's very important. If you look at our AOS concept here in orange on this chart, we do all of the things VMware is capable of doing. We can oversubscribe our resources like CPUs and memories. We've got built-in HA and redundancy. We can do hot add support of CPU and memory. A lot of our customers have told us they haven't seen this from anyone else. So you could be running an application in a VM and you can decide that it is getting starved for resources. It needs more resources. We can automatically increase the number of cores, increase the number of memory to that application, and the application can start consuming that without your having to reboot that virtual machine or restart that application. Very powerful. And finally, we've got container support. So, as the world moves to new models of developing applications based on microservices and containers, we're able to support that natively in our AOS software. On the enterprise storage front, we've talked about the ability to do 200,000 IOPS per second. We have something we call direct block access, which is very important. If you look at something like VMware and you look at some software running in a virtual machine, it typically rides on top of something called a VMDK. The VMDK is essentially a file in a file system, which is VMFS. And then VMFS itself sits on top of LUNs that are exported by some storage component. So you've got LUNs going to VMFS, going to VMDKs, and so there's like 3 layers of translation between the software trying to access a block device and actually getting there. And in our case, we bypass all of those 3 layers and get direct block access. So any one VM going to any one disk can get extremely good performance, and depending upon the workload, we've seen anywhere from 2x to 5x from alternative approaches that have to go through those 3 layers of translation. As we talked about before, you can scale, so you get 200K in a 2U, you get 400K in 2 2Us, and it just keeps scaling that way. And then all of the functions, these are true enterprise storage functions that everyone is expecting from an enterprise storage device, like snapshots and cloning and disaster recovery and thin provisioning and all of that stuff. And we've already talked about the cloud controller and the built-in application marketplace, so I will not spend more time on that. But you can see that lots of value that comes from our 4 pieces of software. And I will add that unlike other hyperconverged offerings, there's really no additional third-party software needed. There's no VMware tax you have to pay. There's no network virtualization software you have to buy. All of that comes when you buy Cloudistics Ignite. So let's now go back and remind ourselves about the 6 business needs that CIOs and IT infrastructure people have been telling us about. And let's review how Cloudistics Ignite Superconverged solution meets each of those 6 objectives. So starting with workload diversity. Well, we told you that we independently allow scaling of compute, storage, and networking. So different workloads that need different balance of compute, storage, and networking, we're able to satisfy all of those different kinds of workloads because of that capability. The second need was for low cost and high efficiency. The way we do that is through complete virtualization, including the network. And so now, even on the networking side, you only have to allocate exactly what an application needs, no more, no less. And so it's very efficient. We don't need any third-party software, which can be quite expensive, thousands of dollars per node for some of our competition. We don't need any of that. Our storage redundancy is efficient, maybe 10% overhead instead of 100% overhead for things like replication. And we've got things like thin provisioning and dedupe and single instance storage. So all of the high efficiency, low cost capabilities are available. We also have very consistent high performance. We've talked about some of the capabilities within the box that contribute to providing consistent high performance. The fact that it's all flash storage, you don't have to worry about spinning disk. The fact that you have direct access to the storage, no 3 layers of translation. The fact that we can do line rate network virtualization because we cut out all of the encapsulation overhead. All of these things make the box very high performant, very consistent. We're not dependent on the data being local to the node on which the app is running, like in Hyperconverged, where locality is very important. So we get consistent performance. And then, of course, we've spent a lot of effort to try and make all of this very simple to deploy, manage, and use. It's really one product. It looks like one product. We didn't have to put lipstick on top of 3 products to make it look like one. Everything takes an application-centric view. You know, the center of the universe is the application. We've got the built-in application marketplace. Everything managed from a single console. Truly public cloud-like management and consumption. We're business resilient. All of our software does rolling upgrades. Everything can be done in a non-disruptive way as you're running. We've got disaster recovery. We've also got microsegmentation, so an application can have its own virtual network, another application has its own virtual network, and you can set up rules about how this application can talk to other applications. So this is all about microsegmentation without needing any separate physical firewall boxes and such. And finally, everything is open and future ready. There's no proprietary hardware here. All of our hardware is standard x86 servers, standard disk devices, flash devices. Everything is standard, nothing proprietary. And of course, we're future ready. We've got Docker support built in, support for containers are built in. So we're already ready for next generation of software development and application development practices. Now, so let's just summarize again, go back to our 6 needs. We told you how we meet them. And let's go back and compare how the siloed infrastructure of the first generation, the converged infrastructure of the second generation, and the hyperconverged infrastructure of the third generation. And let's sort of give ourselves grades and give each of these infrastructure grades. And you can see with siloed and converged, there are challenges in the area of low cost because things are proprietary, they're expensive SANs, they're not really easy to deploy and manage. In many cases, there are 3 products. Sometimes you try to hide that they're really trying to make it hide the fact that there's 3 products, but very, very difficult to hide, as we've talked about before. These are not open. These are often proprietary. If you look at Hyperconverged, I sort of give it half grades for the first three categories. Workload diversity is challenged because of the fact that the scaling is coupled. It worked great for certain workloads like VDI, not necessarily for other workloads that don't really scale compute and storage together at the same time. Low cost and high efficiency, again, I give it a half grade. They do have very low cost storage. The problem is that they use replication, so you have to have twice as much storage as the customer really wanted. And then consistent high performance is difficult to get because with hyperconverged, data locality is very, very important. If your data is not sitting on the same node where your application is running, you're not going to get the same performance. So sometimes when you run it, maybe your data is local, you get good performance. Sometimes your data is not local. Maybe you migrated your workload, your data didn't migrate with you. That's not going to be good, and so there's a lack of consistency in how you get your performance. So I give them half grades on the top 3 rows, and they do well on the other 3 rows. And it's my belief that Superconverged really attacks all 6. Not surprising, because to be honest, we started out saying we've got to attack all 6. We could have settled for generation 1, 2, or 3, but we decided that none of them were really good enough for what we think customers should be demanding. And so that is why we built what we built, why we had to create a new and innovative new architecture. And therefore, it was built from the ground up to satisfy all of the requirements that you see. And that's why we think that we are going to be the next generation of infrastructure that customers will demand, and that I think other vendors will copy and will want to do as well. So to wrap it all up, let me just summarize what I have told you in the last half hour or so. First, that existing infrastructure solutions all the way through hyperconverged are not meeting all of the customer's needs. So we felt the need to innovate and create a 4th generation platform. We've called it Superconverged. As we have told you, it really combines the best of converged and hyperconverged, and then we added 3 more capabilities that made it truly the best to be the on-prem cloud of the future. As a result, you're going to get high performance, low TCO, better than any of the other infrastructures, better than the public cloud, truly easy to manage, completely scale on demand. So it's our belief that Superconverged is the ideal on-prem cloud infrastructure. And of course, Cloudistics and Ignite is the very first Superconverged product. I do not believe it will be the last. I think that we will create a new product category here, and I think others will follow because of how we started out by trying to satisfy customer needs. We started all of this from customer needs, and that is why we believe we have a product that is going to make it so much easier for our customers to consume. So now that I have really excited you, hopefully, about what Superconverged is and what Ignite is, I hope that each of you that has listened to this will sign up to really understand how this actually works. So we've got 2 suggestions for you. First, you can go to cloudistics.com/virtual lab and experience Ignite for yourself directly from your own computer. You'll see this transformational user experience and be able to do all kinds of things directly yourself. And as a next step, or as something else you could be doing, if you really want a one-on-one demo, just send an email to sales@cloudistics.com, and we'll make sure that you get to see a demo. I think that you really do owe it to yourself to be one of the first, and to be able to say you were one of the first to play around with this next generation of superconverged architecture. So we'd love for you to do that, and then give us feedback on what you think. Thanks very much.